Okay, here we are again in the digestive tract, and this time we're going to follow the absorption of alcohol through the digestive tract and trace it along its path post-absorption. So let's first discuss this little ethanol molecule here. And this molecule has a couple interesting features that we're going to want to note because they're going to drive the process that we're going to talk about. So the first thing that we want to note about ethanol is that the molecule itself is quite small. You can see it's not very many atoms large. And then the other thing we'll want to go ahead and note right away is that ethanol is hydrophobic. And these two characteristics together mean that ethanol crosses directly between the phospholipid double layer of cells. It is going to move down its own concentration gradient, and another way to think of it is that the cells that ethanol encounters don't have any defenses against ethanol moving down its concentration gradient into those cells or across those cells, as the case may be. So with that in mind, we want to go ahead and grab our ethanol molecule here, and we're going to move that ethanol molecule into the mouth. Not much happens in the mouth. You don't usually keep a mouthful of alcohol, ethanol, there very long, and so even though we do have quite a few epithelial cells that could cross across, there's not a whole lot of absorption there because it's just not there very long. And we're going to move that ethanol molecule down the esophagus and into the stomach. And the stomach is our first place where we can sort of consider what's going on with that ethanol. So although some ethanol can absorb across the lining of the stomach, there's not as much absorption happening here because we don't have a whole lot of surface area. We've got a lot of lumen and not as much surface area. So we want to address something that is going to happen here, and that has to do with the presence of a small amount of the enzyme in the stomach called alcohol dehydrogenase. So there's the presence of alcohol dehydrogenase in the stomach, and that alcohol dehydrogenase has the ability to break down these ethanol molecules into non-alcoholic substances. That can only occur, that breakdown via alcohol dehydrogenase, as long as those ethanol molecules are in the stomach. So as soon as they move on, we've sort of lost our opportunity to break down any more alcohol into non-alcoholic substances. And we're going to examine that feature in just a minute. So we're going to come back to this spot. So we'll put a little star there because we're going to want to return to how we can sort of control how much time those ethanol molecules spend in the stomach, hence how much time they have to get broken down by alcohol dehydrogenase. So again, key features to note here in the stomach is the presence of this molecule alcohol dehydrogenase and the fact that little absorption occurs here because we don't have very much surface area compared to lumen space in the stomach. All right, we're going to move that ethanol molecule along to the small intestine. And here, because of the way the small intestine is designed, maximum surface area for digestion, and because these ethanol molecules can easily cross the phospholipid double layer of cell membranes, we're going to have incredibly rapid absorption of ethanol in the small intestine. As soon as the ethanol reaches the small intestine, it will be absorbed and be absorbed quickly into our little capillaries of the villi, which will merge to bring us this hepatic portal vein and to the liver. So now our ethanol has arrived at the liver. And the liver is the second location in the body where you have this same enzyme of alcohol dehydrogenase. And the hepatocytes of the liver will pick up these ethanol molecules and begin breaking them down via alcohol dehydrogenase. How much the liver can do that is going to depend upon how many ethanol molecules are arriving. And so we call this concept of how much ethanol can our hepatocytes break down as the first pass effect. So first pass effect, is measuring how much capability the liver has of picking up ethanol from the bloodstream arriving to it and breaking that ethanol down into non-alcoholic substances. It's a function of the size of the liver, the number of hepatocytes, and how much of this alcohol dehydrogenase each of those hepatocytes contains. whatever ethanol molecules cannot be managed by the liver. There weren't enough hepatocytes, or each of those hepatocytes did not have enough alcohol dehydrogenase for the volume that was arriving via the hepatic portal vein. Those ethanol molecules will continue on out of the liver, inferior vena cava, heart, aortic arch, and into the brain. And of course, we know that because that ethanol is small and hydrophobic, the blood-brain barrier has no power over those ethanol molecules. They will cross the blood-brain barrier and enter the tissue of the brain, where ethanol molecules act as GABA agonists, as depressants in the brain. So let's return to this idea that I mentioned earlier, that there's something going on here regarding this time spent in the stomach. So I'm going to grab my ethanol molecule and put it back in the stomach for a minute so we can consider what's going on here. We noted that while there is very little absorption in the stomach, maximum absorption happens in the small intestine, and we noted that we have the presence of some of this enzyme alcohol dehydrogenase in the lumen of the stomach that can break ethanol down. And so it goes to assume that the longer the ethanol spends in the stomach, the more time it has to be broken down by alcohol dehydrogenase, and therefore the less that there is to be absorbed in the small intestine, and we're much more likely for the first pass effect to be able to take care of or manage all that ethanol that's arriving to the liver. How do we get ethanol to spend more time in the stomach? Well, you might remember that if we eat a fatty meal, I'm going to just put some little yellow stars in here like they're fat lipids in your meal. If you eat a fatty meal, it is much more difficult for the stomach to utilize its muscle movements to emulsify that fat into the chyme. And as it takes longer and longer and longer, the stomach is churning and moving to intend to emulsify this fat and mix it in with the rest of the chyme. We've got more time for good old alcohol dehydrogenase to do its work, and less alcohol that makes its way to the small intestine. So if you're drinking a glass of alcohol and you don't want it to go to your head, then the thing you should be eating with that glass of alcohol is lipids, because the lipids slow the gastric process and provide more time for alcohol dehydrogenase to do its work.